Okay, we're in section 126. There'll be contents to look over, examples to do, and then exercises to work on. My name is Ron Bannon. This is a draft version of my adaptation of Webster Wells' Advanced Course in Algebra, which dates back to 1904. The PDF that you're looking at here is only for the participants of the Prison Mathematics project. All right? Now, I will publish it later on. My email address is Bannon, that's B as in boy, the @ symbol, nnon.us. Let's look at the contents. And the contents over here, basically you read through it. I did copy a graph from Wells's text. It's right there. I want to claim that what I'm doing problems though is I create graphs for you as well, and the graphs I'm doing machine. As you can imagine, Wells had no machine to graph. He had people that were doing the graphs. All right, they didn't do a bad job, but this is I would call this a pre-calc sketch. All right, now my graphs are much more detailed, but I do indicate on my graph like easy points to come up with. Let me show you what I mean by that. So I'm going to say easy point, easy point, easy point, easy point, easy point, easy point. All right? So the deal about this over here is that, having a graph is really convenient. And certainly, I know they put a graph over here, but I'm going to claim over here machines can generate graphs pretty quickly. You should have a rough idea, though, that you can get a pre-calc sketch pretty quickly. Again, this is not a pre-calc sketch. This is a sketch that actually a machine created. All right? So I'm going to say over here, let's just go to the examples. And I got a picture. Now I want to point out some of the features I'm seeing in the picture for you. Let me just go through this briefly. I'm seeing 1, 2, 3 roots. I'm seeing something over here which we call a relative maximum. I'm seeing something over here which is a relative minimum. Now this particular graph goes on forever. What I mean by that, although this is just a partial picture, and it does indicate that, it goes on forever, which means it goes up and down, all right? So, we really can't show you the complete picture. This is just a partial picture. So what they want me to do is use the graph to locate the roots. Now, whether this is a pre-calc sketch or a good sketch, we can approximate the roots of this. So looking at this one over here, I'm going to say, kind of looking at it, I know it's between 2 and 3. Looking at this, I'm going to make a wild guess. Not really a wild guess. It looks about 1. And over here, I'm not saying it is 1, but I'm saying it looks like 1. Now here it's between, I'm going to say -2 and -1. Now, I made some guesses at it, and someone says, why do you have to guess at it? Because I don't know exactly, but I do know this. I know this is the function, and I'm claiming that I'm looking at it, and I'm claiming it really does look like one of the roots is about -1.3. That's right over here. I'm going to have -1.3 there. I'm going to claim this looks like 1. We'll verify this. And I'm going to claim that this looks about 2.3 to me. Now, someone says, how could you go about verifying that these are actually true or approximate? Well, I'm going to tell you the 1's really easy to do. Let me write this down for you. So f of 1 is equal to 1. I'm plugging it in here. -2 plus 3. It's a root. It clearly gives me 0. What I mean by that, the point would be 1, 0. Now, these are more difficult to do, but I want to point out I don't mind you using a computer to do that. And what I'm claiming over here, if you evaluated f of -1.3, what do I mean by that? Well, it's going to be -1.3 cubed minus 2 times -1.3 squared minus 2 times -1.3 plus 3. If you do this on a computer, you get this number over here. And my claim is approximately 0. It's not the 0. If you did 2.3, what am I saying over there? That would be 2.3 cubed. Again, I'm plugging into the function. Minus 2 times 2.3 squared minus 2 times 2.3 plus 3. You would get this number over here. Again, it's approximately 0. They're not the zeros, though. I wouldn't claim that for a moment. What I'm claiming, though, is that I probably could find the other roots exactly. And I want to go through that with you. And the way we do that, let me get my eraser out. And I'll tell you why we can do it now. Just give me 1 second here. Sorry about that. So I know I have a root, and the root's 1, which means f of x has a factor. What's the factor? It would be x minus 1. But what I don't know is what remains over here. This is called a depressed quadratic at this point. So what I want to do is I want to do the long division. I'll write that down for you. On the next page, I'll write the long division down now, which is x minus 1 divided into x cubed. This is f of x, by the way, minus 2x squared minus 2x plus 3. Let's go through it. X squared, I'll do my multiplication. That's going to be x cubed minus x squared. Now I realize the work is over here, but I'm going to go through it and explain it to you. We subtract. What do you get? Minus x squared minus 2x plus 3. We repeat. Minus x. I know I'm going to get a 0 remainder. Minus x squared. Let's see, what do you get? Minus x. I'm sorry, not minus x, plus x. Let me make sure I did that. Minus x squared, yeah, plus x. Subtract, you get minus 3x plus 3, and then I put down minus 3 over here. What do you get over here? Minus 3x plus 3. As we said, remainder 0. So it's going to be x squared minus x minus 3. Let me do up here, get this erased, and I'll put that down for you. So it's x squared. Again, I want to point out we just did the division. So x squared minus x minus 3, right? Oops. Now what's nice about this, we can actually continue to factor, but there's no way I'm going to get finger numbers from that. And the reason that if I try it, x and 3 and 1, it's just never going to give me that middle term. So we need the quadratic formula. Let me write this down, and we'll put the factors down in a moment. X equals, well, what do you get there? Let's put this down. You're going to get minus b, which is 1, plus or minus the b squared, which is 1, minus 4 times a times c, which can be minus 12, so it's plus 12, over twice a, which is 2. So what do you get? X equals 1 plus or minus the root of 13 over 2. All right? So, I'm looking at it, and I want to factor it, to be honest with you. And a lot of people say, do you really need to factor it? I want to factor it. All right? So I'll write this over here. X minus 1. I want to point out the two roots I'm seeing is x equals 1 plus root 13 over 2. The other one is x equals 1 minus root 13 over 2. So what do? I write x down minus the root. This looks kind of strange to me, though. I don't think it's right, but I'll write it down. I'll tell you why it's not right. I got a fraction there. I'd say I get a quarter out of that, right? I'm going to do something, all right? I'm going to see if I can do that. And I'm going to write this down. I don't like that 2 there. I really don't. So I'm going to multiply by 4 and divide by 4. Let me write that down for you. Multiply by 4 and divide by 4. I'll tell you why I'm doing that in a second. I'm just writing down what I'm looking at over here. Again, this might be overkill for you, but let's take a look. So I'm going to say 1/4. I'm taking this 4, which is 2 times 2. I'm going to associate one of the 2's with this, the other 2 with the other factor. So you get x minus 1, and then you're going to get 2x minus, right, I'm multiplying the second factor by 2, you would get minus 1 minus root 13. Whoops, I made a mistake. I didn't put the x in there. I'm going to associate the other 2 with the other factor. You get 2x minus 1 plus root 13. All right? If you want, you can multiply it out. I don't think it's necessary, but I know all roots now. I think you should check it And someone says, do you really need to check these guys over here? Yeah, you might want to multiply this thing out and make sure when you multiply it all out, you get this thing back. And that might seem overkill to you, but I got all my roots now, all right? I got all the roots, right? What am I talking about? I've got the root x equals 1. We did that just by looking at the graph. Then write that down. And remember, we just used quadratic formula. Let me go back over that. We'll check the key later. And what I get 1 plus or minus root 13 over 2. I want to put these answers all written down for you. And I also want to point out I use a calculator to approximate it. And lo and behold, the approximates, I got that. Right in the beginning, I had those same approximates looking at the picture. All right, let's talk about what you need to do now. All right, now certainly I'm hoping that you have some comprehension of what you just read, comprehension of what we just did, with the looking at the picture and getting the roots. Again, sometimes looking at a picture, you really can't get the roots, but I was kind of thankful for this one over here, that if you can find one good root, and I thought the root was 1, and it does work out, you can actually use that to find other roots, which is important. We do that by long division, by the way. All right, so I'm going to say that's done. And then what are you going to do? You got to reinforce what you've learned. Exercise, all right? So I'm going to say what I do, I provide to you, because I realize some students don't have access to the computer, I provide to you a graph. And what does it say over here? Locate the roots. It says, can you approximate the exact? And I got to be honest with you, looking at this thing over here, and I'll put what I mean by that, looking at it, I'm going to say that, integer-wise, they're definitely not integers. I know that much. But, you could approximate them, and that's all we're asking you to do. Now, of course, when you approximate something, we want to see if you can verify it. So what I say, looking at the picture, I said something like this over here. And I want to point out, if you evaluate the function at those numbers, they wouldn't be 0. They'd be approximately 0. All right, so I'm going to say, by looking at the picture, we did not find the exact roots. We did not find the exact roots. Right, we found the approximate roots. But that's not a bad idea to find approximates, all right? By the way, the graph gives me a lot of information. Not only did I get the roots looking at that, notice 3 of them. I notice there's 2 points over here. And this point up here, let me circle it for you. That's a relative maximum, and this point over here is a relative minimum. This graph goes on forever, by the way. And it's a partial picture of it. Let's look at the next picture. I'm looking at this one over here, and certainly I'm looking at it, and someone says, are there any roots over there? I would say there's no real roots, all right? There are no real roots to it. Now, someone could say, could you find a complex roots of it? Well, I go through that. I actually go through that. You want to look at that. Make sure you can do that. This is a 4th degree polynomial. We are expecting that there'd be 4 roots to it. And I wrote all 4 roots down for you. Make sure you can match those answers, by the way. This is a cubic. We do provide a picture for you. Picture's over here. Looking at it, I can approximate the roots, but I'll be honest with you, they don't look like integers, but you can still approximate them using decimals. And that's exactly what I did over here. I approximated them using decimals. Again, I'm using a computer to show you that they're not really 0. They're approximately equal to 0, all right? Over here, using a graph, and again, the graph is on the next page, approximate the roots. Let me take a look at the picture. And looking at the picture, I'm going to say, it sure does look like -4. It sure does look like -2. It sure does look like -1. I want to claim, though, that may not be 100% true. Like someone says, oh, is it really going to be -1? Is it really -2? Is it really -4? I don't know that. I have to verify that. So what I did was I wrote it down. I wrote these over here. Again, let me point out what I mean by that. I thought -4, -2, and -1 were good answers. They're integers. They're easy to look at. And I verified. What I verified? That the function actually evaluates to 0. What's the function? The function is x cubed plus 7x squared plus 14x plus 8. And I verified each one. And yes, you're allowed to use calculus if you want to. Let's look at the next one, which is number 5. And they said the graph is figure 326. That's right over here. And I'm looking at it, and I'm going to say, again, it looks really simple. I'm not saying they're right, but I'm saying it looks like 1, 3, and 4. Go back over here, and that's number 5. I'm saying 1, 3, and 4. Let me scroll. I put the 1, 3, and 5 down, and then I verified that, in fact, the function evaluates. Let me write down what the function is again. The function was x cubed minus 8x squared plus 19x minus 12. I actually verified it's 0 in all 3 cases. All right, let's look at number 6. They give me the graph. I'm looking at it. And again, I'm looking at it, and I'm going to say, I'd have a tough time telling you what these numbers are exactly. But I do know, one of them is between -2 and -1. The other is between 1 and 2. The other one's a little bit after 3. So I put down what I believe are approximate answers. And again, I want to do the verification that they're really not 0. They're approximately 0. All right, let me look at number 7. Number 7, I'm looking at it. What do I see? -3. Say -3 looks like a good solution. 2 looks like a good solution. Over here, it's between 0 and 1. Over here, it's between -2 and -1. So what did I do? Again, I want to claim to you, I think the integers look really easy to me. And I'm going to claim that, -3 looks like a good one. That's right here. And 2 looks like a good one. That's over there. These are approximates, by the way. What I do, I verified it. I actually verified that f of -3, right? I write that down over here. That's x1, by the way. I verified it was 0. And I verified that f of x2 was actually approximately 0. So that's not really the 0. I verified that f of x3 was approximately 0. And again, you notice I got these labeled x1, x2, x3. And I verified that x4 was 0. Now, you can easily find the other ones by doing a long division. Let me point out what I mean by that. If I know, I'll write this over here. If I know -3 is a root, I know a factor is x plus 3. And if I know 2 is a root, I know x minus 2 is a factor of the problem. What I don't know is this over here. What you do is you multiply this out, which would be x squared plus x minus 6, and you divide it into the polynomial x4. And you'll get a depressed quadratic, which is really easy to deal with. I mean, it's much easier to deal with than a fourth-degree polynomial. And this is important. It's an important technique that you want to pay careful attention to. All right? So I'm going to say that's doable, and you should be able to verify that these are also roots. All right? SAGE, let's just go back over that again. What's SAGE? It's a computer algebra system, or a CAS. It's open source software, but it's free to download. You have to pay for it. That website there is a good place to go to. You download the software or use the interactive web-based application. You may want to look at the code, try to make sense out of it. All right? Try to make sense out of the code if you're looking at it. My goal here, though, is this, that you look at the problems that were given you, right? You work through it, and you try to make sense out of that. If you think there's any errors, including you say, oh, your graphs are no good or whatever, please reach out to me. What's my name? Bannon. What's my email address? Bannon, which is B as in boy, the @ symbol, NNON.US. All right? So reach out to me if you think there's any problems. Thank you for your attention.